About 1 million Ugandans have access to computers. The figures are still low compared to the developed countries. For instance, about 120 million people in the United States of America, according to statistics from the US Census Bureau, have access to a computer. In the past decade, there has been an increase in the use of information technology, with new applications coming on the market. For example, Skype technology enables one making calls using a computer connected to the internet, and teleconferencing, which allows meetings between people in different places with just a twinkle of an eye. What drove this transformation? Where the laptop and palm top are increasingly becoming items of common usage. And where is it heading? If we are to try to review back in time, the first computer ever in Uganda was unwidely mainframe, falling into first class of computers. This machine arrived in 1967. After Uganda attaining its independence in 1962, there was a rise in government workers, so the computer was brought to help with the management of public servants' payroll. A year later, after the first machine, the second mainframe arrived and was taken to Makerere University's Department of Mathematics. In the early years after independence, usage of computers was largely attributed to a certain privileged class of experts or dignitaries. Now not only IT professionals use computers, but the everyday person, especially in the urbanized part of the country. The noisy typewriters have been replaced by soft touch and sensor keyboards, and work which used to take 2 days during the era of the mainframe now takes less than an hour to complete. Productivity levels have definitely moved up with this development. Almost all universities across the country offer an IT component on their program prospectus, which means that the critical mass required to service the growth is being built in tandem with the increased access. Down the years, particularly in computers, there has been an evolution from mainframe, which were large, to laptops, to microfused computers. A Ugandan company has ventured into computer manufacturing by developing a low-cost computer to enable people like students who cannot afford expensive desktops and laptops to acquire one for work, entertainment, and business. The device is a low power consumption that can enable people in the rural areas execute their duties. It is a portable computer which can enable people like lecturers and business executives to carry less baggage to their classrooms. It is a powerful yet contracted computer IPTV streamer available in 3 colors, with amazing performance and PC boot up in less than 4 seconds. Speaking to Karugaba Ivan, the mind behind this development, he elaborates the source of this innovation.
The reason why we did this product was, even from statistics, Uganda Bureau of Statistics, Uganda is not well placed in terms of ownership of computers, because only 5% of Ugandans, actually less than 5% of Ugandans own computers. You can refer to the statistics of 2021 from UBOS. But quite a number of Ugandans actually have TVs, and the figure stands at around 22% of Ugandans. So what we thought as a company was to design a product that can actually fit within that void. Yeah, so we want this to be a household product, whereby most households, of course, majority of which have TVs, can access this product cheaply, because it costs around 200,000. That is the starting price. So that price point is quite favorable, in that even the commonest person, a border man, can buy this device, take it for his kids. The kids will be happy, they will have a computer to use, such that at least because ICT has become an essential, even at A level you either do sub-math or ICT. So building the culture even from the grassroots, from the homestead, kids being used to computers, it will play a really great role in a transformation of Uganda.
It's a talk for every innovator that it's never an easy journey, most especially in the world of entrepreneurship. Managing a startup is very technical. Many have the vision, but execution is always a mile away from occurring. But the most important of them is validating the idea. Let's have a review of his journey to finally have this output.
Another important thing is validating your idea. Of course, this idea in my context was quite valid because it's quite, even at campus, you can go and see very many students actually during COVID, most universities had to shut down because students didn't have the required infrastructure back at home. They didn't have computers, so Makerere, Chambogo, they had to close down. So once we validated the cause, it was not an easy journey because we started this research and development in 2016. So it has been a cool around 5-6 years. And from the start, in around 2015, we did some end user analysis, consumer habits. Yeah, something common among people who design products because as corporations and businesses, we design products for people, not for ourselves. So when you look at the end user habits, their requirements, that was 2016. 2017, we had a first version of our product. It wasn't easy because getting the finances to designing wasn't hard, but manufacturing of the product was quite challenging. And in 2017, I had to fly to China. I had to work with the factory to supervise the engineers in the factory to have our products accurately produced, the first version. Then by the end of 2017, of course, we had the working, call it a minimum viable product, something that addresses the problem that is existing in the market. So with the minimum viable product, we tested a few things. Is it working? Certain software platforms run. Most of the testing was in-house. Then that phase was around 1 year. Then in 2018, we pivoted, and actually the first version of this product was bigger. So we pivoted and looked at some metrics. How do we reduce the cost of this product? So we downsized the product further, miniaturized it such that the manufacturing cost goes down to meet the consumer habits of Ugandans, because Ugandans want affordable things, want cheap, but which deliver quality. Yes, so we miniaturize the device but deliver even better quality in the same place.
Many Ugandans are full of doubt when it comes to locally developed products, which has forced majority to pay for foreign-based products and softwares. Karugaba says it's not the case this time around after obtaining special skills from Shenzhen, a global center in technology, research and many other tech-based activities.
In terms of reliability, this product is actually very robust, meaning it will handle all the tasks that are given to it, because I personally, if you other people have used, for example, at home for my entertainment and maybe checking emails, TV. I have the device. It has been connected to my TV for the past 2 years. It has never gone down. And even from our other customers that have experienced, it's quite reliable and robust. The reason being is as we designed this, first of all, what we did was to modularize device. And apart from modularization, where in engineering, it's something to do with not making maybe one board or making multiple boards or subsystems of the device, such that failure in one system doesn't really affect the failure in another subsystem inside the maybe the electronics architecture or the structure. So and another thing, what we did is to ensure at least we have as minimal parts as possible. For example, in an ordinary laptop, the ones that are not so expensive, engineers deploy hard drives, and hard drives or HDDs have movable parts inside, and the disk is spinning. So you may find if you overuse your laptop as you move, the hard drive health will degrade. So those extra mechanical parts, maybe the fan that cools the CPU. So in our product, we actually deploy solid state technology. We don't have mechanical moving parts inside here like fans, hard drives. So we have technologies like actually for the memory we do use something called, it's not SSD, but it's called eMMC, eMMC storage that is quite similar to SSD. So eMMC is a simple chip on the board. Then also for cooling, we deploy something called passive cooling strategy, whereby the device doesn't need a fan that is keeping on spinning. Sometimes when those fans die, they'll start making noise, and sometimes if the fan doesn't run, the computer will overheat and restart. So those are some of the design strategies we deployed to ensure our product is as reliable and durable as possible. But also, lastly, we ensure we offer technical assistance, instant technical assistance, such that if you have our product, should it develop any problems, hardware or software, we have a team that is ready on standby to work on that device.
I've been working with this device for like a month now. So I think what it does, this device it makes life easier. That's what I'm going to say first. Because imagine having a display that is not. There are very many screens these days. You know that gap between buying a screen that is smart and it's not smart. You may find same screen size, same brand, but with the word smart, the prices are high. Yet this device gives you more than what a smart TV can give you. So buying it and plug it at the back of a screen it opens you to the world of computing actually. Not even what a smart TV can do, and at such a price. I think it's a deal. It's a good deal. With it comes with all the apps you require, everything you need, VLC, you need to edit a document. It's as simple as that.
And foremost, I bought a microfuse computer when we had to go and see how the innovators are doing their work and why the ministry should continue supporting them. When I saw the simplicity, the portability of the device, I fell in love with it. What I did, I procured one for the start. I went and tried it home, which also saved my interruption with my laptop and my family. So when I connected the microfuse device on my screen at home, it helped me solve a lot of things at my home. My family would use that. I would concentrate using my laptop, which to me was a very good idea and innovation.
Let's now take a brief review on the technology behind this device, observing the interior blueprints inclusive of the 3D model.
This is a 3D model of our device. I think you can see. So a 3D model is simply a design that is in digital or computer format, and you come up with this 3D model after doing a process called industrial design, where people sketch the device, then you hand over the designs to a mechanical engineer. The mechanical engineer will do the 3D modeling and coming up with how the product is going to be assembled together. So this is a product assembly showing all the subsystems from the USBs. You see this? So when it comes to manufacturing, as I mentioned earlier, these plastic parts, there's a part which is the top, this top highlighted blue. Then there is the bottom, this bottom. So you generate files which a machine can understand and reproduce multiple times with different production techniques. So this mechanical 3D model also has the circuit board, this brown layer you see. It's the circuit board or the PCB assembly. And that PCB assembly is actually generated by another type of engineer called an electronics engineer. So I think you can see it here. So this is a printed circuit board layout, PCB layout. These blue lines you see, I don't know, on chips you usually see lines. Those are either signal lines or power lines, supplying power, because power comes in from one source into the device, then you have to distribute that power across all capacitors, the microprocessor, and different other electronic components in the device. So this is the electronics circuit board. Yeah, these are the schematics. Then to generate schematics, you start with, okay, these are the schematics, then the other one is the PCB layout. So all devices have other tiny mini schematics. For example, to design the HDMI port, there are around 19 connections you need to make from the board, and signals coming from the processor and RAM, and yeah. So then the SD card slot, these are schematics on how you connect. So all the subsystems of the device actually put together into one schematic, then you generate a board. Now you export these files into this 3D environment. These softwares can actually interact. For electronics, we use a software called Eagle for electronics computer aided design, or to design the motherboard in lay terms. Then for the structure, we use a software called SolidWorks. And let me isolate, for example, this bottom part. I think you can see I've isolated it out. So it is a very, very powerful software, and I can exit the isolate. I can go back and view the top, this top part. Let me isolate it also. I think you can see this is the top part. So this software, apart from doing the product assembly, you can actually do what we call the product simulation. For example, if the CPU, if the product is functioning and the CPU is generating heat, or it has a certain temperature of maybe 70 degrees Celsius, how is the product going to get rid of the heat? So there's what we call simulation, whereby each device that generates heat, because from the data sheets you get to know how the heat is flowing within this closed environment. Then you come up with design strategies to get rid of that heat. So since we use passive cooling, it will cool by convection. Air will come in through this other side, go over the different components, including the CPU, and come out from this side. Yes. So that is it in brief.
Alex Lackey and Conrad Nsubuga, volunteering with the company, are taking us through brief demonstrations of their experience with the device. Let's have a look at the connection pattern and also observe the interface.
Okay, basically to set it up here, you need to first connect it to the display. It uses a HDMI, whereby the current monitors that we have, most of them have HDMI, and I'm very sure that almost these days almost everyone has a smart TV and a normal flat screen TV. And as we know, all TVs these days have HDMI, and even projectors. They also have they have HDMI. So you have to first connect it to your HDMI cable, which is connected. In our case, we have a monitor. It's connected to a VGA cable. Then you connect the OTG, these OTG adapters for the mouse and keyboard. Then this is for power. It's connected to a charger, and all of these, the charger, the HDMI cable, even the OTG, come with a device. Let's wait for it to pull up. From the box, it comes with an air mouse or air keyboard, which also has it's a keyboard, and at the same time it has a mouse. Then an adapter. Plus HDMI cable. So here, okay, now the computer that has fully booted up, we can see this is the user the setup menu, and from here we can access the basic functions like Microsoft Office. Let's say if you want to create a Word document, then let me see. We also have other applications, like if you want to watch a movie where you have VCL already installed. Let's see if this document is not now ready. If you say start, now this is where you'll do your typing. All your typing you do from there. That is, if you want Excel, you can also Excel. You come back to this place there. For movies, I'm very sure that majority of the users are familiar with VCL. Then we also have provisions, like we have provisions whereby so if someone doesn't want what's the device for, okay, for this, like let me say you have bought a device and you have bought it for entertainment for your kids, you can also customize it for you to be having games, like supporting games, but the drawback is that you won't be having these office features, browsing. So the basic applications that one needs, like a daily Ugandan and a normal Ugandan needs, are already available on this device.
This is what you get as a user. This is what ships. This is what you get. This is a product. In it is a device and the control and the charger at the bottom. So, and this is how the interface looks like. Sorry. So this is me after connecting. If I would like to edit a document, I just click here and it opens up. Excel, everything is here, even Chrome. Basic computing. Sorry. That's Chrome. You can Google anything you want. Anything. It's just that it's not connected. Wi-Fi here. Office. This is what. this is Word, and you type anything that you feel like. And there's a lot more. There is a lot more. This is Excel. You can do whatever you want to do with the Excel sheets. There it is, working perfectly well, and I've been using it for a while now. Then a player, if you need to play, to play a video or something. Then Steam for the gamers. And that's it, you have your computer with you at 200,000.
Karugaba has attributed the success of this project to teamwork, and he explains to us the production chain distribution, outlining the different partnerships in place to facilitate final product output. This is important to the manufacturing industry.
I can say on this planet, there's no single company that will make every single component of its either car or laptop, or because even Apple, of course, okay, let me just describe the ecosystem. They are what we call original equipment manufacturers, OEMs. Then there are companies now that do electronics manufacturing services. For example, Microfuse. Microfuse is an electronics manufacturing service company. So we look at people's problems and design devices that will address people's problems. So when you design a device, as you design a device, you are going to employ an OEM's device. For example, I can say my design strategy is, let me use an Intel CPU in my design. So Microfuse won't have to go all the way reinventing the wheel to make the processor, to make the capacitors. So as you design a device, as you generate the blueprints, the schematics and all that, you will use several components: capacitors, resistors, inductors, CPU, RAM. Find RAM is like from Samsung, you see that. So what actually happens is, after you designing, you will go to another process called sourcing. Sourcing is whereby the end product of a design is a bill of materials. For example, if civil engineers are designing a structure, for example, Mapira House or NSSF building, the architects are going to sit, design, civil engineers sit, do the same thing. Then they'll generate a bill of quantities. How much sand do we need? How many iron bars do we need? So you will find that the design of the building, the architectural firm, won't have to be the factory that is going to make the iron bars. It won't have to be the one mining the sand and all that. You see that? So that is an analogy in terms of commonly what people see. So after designing, you source the bill of materials for whatever you have, the design strategy, the components you have specified. You will source them. Then after sourcing them, you'll generate the bill of materials. If you have a production facility, it will be quite easy, because now, for example, our product, it's made of two major bill of materials: the plastics, any part, the structure, even this laptop, and even a mouse. So there are these plastics, then now there are circuit boards and other electronic components inside. So from the plastic bill of materials, you can easily actually do what NICE does. There's a process called plastic injection molding, whereby you'll get a metallic mold and inject, like how they make cups. It's the same process, simple. And you make hundreds of thousands of the plastic enclosure. Then when it comes to electronics, you start with what is called the bare board, a motherboard without those small components. Then after sourcing the components will be put by machine very fast onto the board, then will undergo what we call reflow, soldering, and some other processes. So people should not mistake assembly and manufacturing. Actually, assembly is part of manufacturing. You see that? But you can be a manufacturer and you're also assembling your own devices. And part of manufacturing is design. Design goes hand in hand with manufacturing.
There has been a low level of adaptation of local innovations due to a number of factors, but mainly competition. Karugaba believes that laying strategies for global competitiveness will boost a local demand.
About global competitiveness, the first strategy we put in place is actually filing intellectual property. Because when you speak of competitors, someone would actually get this device, maybe reverse engineer and mimic. So, but you may find they may not come to the same device, but they have something similar, a mimic of your product. So, any innovator out there, intellectual property is something, as an innovator, before you make a sale of your product, at least ensure you protect your intellectual property. From as simple as the brand, the logo, you see, the trademark microfiche, you see that? Because one day someone may wake up, come from Asia and make like jumpers with microfiche, or ride along, or come with other devices. So if you haven't protected your trademark or the other intellectual property about your device, you will be outcompeted. And the other approach we use to stay competitive is delivering quality. At least we ensure, as we design and manufacture our devices, we give out the best quality, because the contract manufacturers we have now, our devices go through quality checks, quality control, and so that actually keeps us competitive. In that, when you give your device to someone, it's quite reliable. It has gone through certain certifications. You see that? Yes. Then, as I mentioned earlier, the last point about competitiveness is, as engineers, we have to always go back to the drawing board and ensure we make this product as affordable as possible. Today I've come, it's 200,000 Ugandan shillings. That's about $50 US. Our strategy is, when you come back after a year, the same product will be 150,000 Ugandan shillings. So that is a strategy companies use, because as you scale, as you make more and more, the unit economics actually becomes more favorable, because it will become cheaper and cheaper. You'll enjoy economies of scale. So that is another strategy we intend on using. Yes, to always make, you see that, our products deliver the same quality and power and efficiency, but at a lower cost, because the reason why actually Tecno, Infinix are quite successful in Uganda and Africa is cost. You cannot, I don't know, the consumer habits of Africa, it's a game of cost, so it's a game we have to play well.
Dixon Namisi, Head Digital Media Unit, Ministry of ICT and National Guidance, calls for aggressive publication of such outstanding innovations, which will be key to suppress foreign competition, encouraging global competitiveness.
Microfuse 1 is a very good device. However, people don't know about it. Those of us who know are the elites, and we are very few. We are very few who know about it. Personally, I have bought so far 3 pieces of it, some of which I've given to my team members as gifts for their good performance. But very many people out there don't know about Microfuse. They need to invest in quite a lot for the world to know that Microfuse is the way to go. These Microfuse computers, first of all, they're cheap. I bought one at 250,000 initially. It comes with a complete set of what you need. But how many people out there know? How many people back in Mbale know about it, where it comes from? And how many people within government also know about Microfuse? So it ends within the ICT fraternity, because we sponsor them, we manage them, They are our innovators. Understand? So they need to get out there and talk about microfuels and why people need to embrace microfuels. That can happen only if they are to involve other stakeholders. If they are to say government should embrace microfuels, how are they going to do it? Can Ministry of ICT give them a platform? Yes, it did. It has at least given them a bigger, wider platform. They give them finances through the Innovation Fund. The question is, how are they going to push it beyond their space? How are they going to enroll it across? So they have a bigger challenge to make the world know about microfuels, to make the community they're in to know about microfuels. It's a very good device. It's a simple device. Anybody else can use it if well connected.
Digital infrastructure has developed significantly across Africa. Uganda has a fast-tracking digital technology and infrastructure, the likes of which are used in the development of smart cities, smart offices, and cloud strategies. This is to achieve the country's Digital Vision 2040. Barija Andrew, Smart Tech.